Very good evening, students. Wish you all a very happy Children's Day. So hope you all celebrated today's day and you all would have got many functions, isn't it? Attended many functions in your schools. All right. So with this good note of celebrating the Children's Day, we are starting our class today. So welcome to Jatadhara Educational Technology Program. This is a free coaching classes conducted for Nmmss exam 2025. Right. So in today's topic, we are going to see Venn diagrams and LCM and HCF. Okay. So very important chapter, especially Venn diagram and your LCM and HCF also. All right. Now let's move on to the mental ability Venn diagrams. Okay. So after this, we'll see those two things. See this question. In a class of 40 students, 20 play kabaddi, 25 play volleyball. Each child plays at least one game, right? So now let us represent volleyball and kabaddi players with Venn diagrams, right? So this is how this Venn diagram is being drawn. So here, kabaddi, 20 students are playing, volleyball, 25 students are playing. So there are three regions in this Venn diagram, right? So the middle one, what does it represent? So since both are intersecting, okay, there's a common point. So this is called where the students play both kabaddi and volleyball. Okay. So at this point, the students play both kabaddi and volleyball. Okay, right. And how about this? The right arrow that is showing now, students play only kabaddi. And the left one, students who play only volleyball. Right. So see here. Yes. So let us represent volleyball and kabaddi players with Venn diagram. So in the class, there are 30 students and each play at least one game. So volleyball plus kabaddi. So volleyball is 25. 20 play kabaddi, 25 play volleyball. So it is 45. But there are 40 students. This means that 5 students play both. So they must be written in the overlap. That is where these both meet. Overlap, yes. The correct word is overlap. Right? So this 5 has to come in this overlap. And there are 20 kabaddi players, of which 5 are common. So 20 minus 5 is 15. Only 15 play kabaddi. All right, students. So this is how you subtract and write it correctly. So there are 25 volleyball players, of which 5 are common. So 25 minus 5 is 20. Okay. All right. So now in a class of 40 students, 20 play kabaddi, 25 play volleyball. Each child plays at least one game. So here we are representing Kho-Kho. So let us represent kabaddi and Kho-Kho players. Okay. So forget about this highlighted in yellow color question. Just we are going to learn the concept, how this Venn diagram has to be drawn and how through that the answers can be reached. Okay. Right. So the first one says Kho-Kho. Second one says kabaddi. So in the class, there are 30 students and each child plays at least one game, kabaddi and Kho-Kho, 20 plus 15, 35. But there are only 30 students. So this means that 5 students play both. So they must be written in the overlap. So there are 15 Kho-Kho players, of which 5 are common. So 15 minus 5 is 10. So 10 play only Kho-Kho. Okay. There are 20 kabaddi players, of which 5 are common. So 20 minus 5 is equal to 15. So 15 play only kabaddi. All right. Now let us answer some questions, students. So you can answer these questions. In a class of 50 students, students play at least one of Kho-Kho kabaddi games, right? Right. Now, how many play Coco in this? Right. So you can actually answer this. You think over it. You can think over it and give me the answer. Just find out the answer and keep so that when we announce the answers, you can check. So how many players are there? How many players who play Coco? Obviously, 19 minus common 1. So which is 8, isn't it? Yeah. So the how many play Coco? It is not only Coco. So the question says how many plays Coco means 19 plus those students also play kabaddi. So you should include that also, right? So 19 plus 11, which is 30 play Coco. How many play both games? So how many play both games? Which is the overlap, that is 11. How many play only kabaddi? So only kabaddi is what? They should not play Coco. So it is 20 minus 0. Nothing is there because we have already written 20 in kabaddi. And in Coco it is 90. Okay, so 20 minus nothing. How many play kabaddi? So how many play only kabaddi? How many play kabaddi? Right? So the question actually, we should understand the question and then give the answer. How many play only kabaddi is 20. How many play kabaddi is 11 plus 20, which is 31. Right. So with this, we are moving on to the next question. In a class of 75 students, students have to choose at least one of dance or painting. Okay. So in a class of 75 students, students have to choose at least one of dance or painting. Right. So the question is, how many choose dance? So 1 second can be given to you, not more than that. Quickly find out the answer before that. How many choose dance? So I'm sure you have got the answer by now. Yes. So how many choose dance? It is 21 plus 21. So 42 students have chosen dance. How many choose both? It is 21. How many choose painting? Right? So see the question, how many choose painting? And your answer is 21 plus 33, that is 54 choose painting. All right, yes, see the next question. In a class of 20 students, students are given an option to choose football or cricket. So 3 students did not choose any game as it was optional. What do you mean by optional? Not compulsory. Okay. So optional means not compulsory. Right. Now, so see here, 3 students did not choose any game as it was optional. So number of game is 3. So the total is 20. Right. And the question is, how many choose football? Okay. So how many choose football? Think over it and then give me the answer. So how many choose football? It is 7 plus 4, which is 11. How many choose both? Obviously, it is the overlapping place, isn't it? So how many choose both means overlapping place, that is 7. Right. Now, how many choose cricket? How many choose cricket? It is 7 plus 6. Okay, because the players who are playing football will also play cricket. Isn't it? The question does not ask how many plays only cricket. The question says how many choose cricket. That's all. So it is 7 plus 6, 13. All right? Yes. Now let us discuss little difficult questions. Right. So now just look at this question. In a class of 40 students, students have to select at least one of the three games: football, cricket, and tennis. Okay. So in a class of 40 students, students have to select at least one of the three games: football, cricket, and tennis. The question is, before we go on to the question, let us see what does each number say. So the 7, which is common among everything, say it means that this number indicates students who play all the three games, which means the 7 students play football, cricket, and tennis. Right? So 7 students play all the games. Right. Now see the next question. This number indicates students who play both cricket and football. Okay. So this 2 indicates students who play cricket and football. Both cricket and football, but not tennis. This 4 indicates, this number indicates who play both cricket and tennis, but not football. Okay. So this 4 indicates students who play cricket and tennis, but not football. Right. Now this 5 indicates students who play both tennis and football, but not cricket. All right. So I repeat, the 5 indicates students who play tennis and football, but not cricket. All right. See the next question. In a class of 35 students, students have to select at least one of the three games. That is football, cricket, and tennis. Right? Yes. So this indicates students who play only cricket. 4 indicates students who play only football. 7 indicates students who play only tennis. Now let us answer a question. Right? So see here, in a class of 50 students, students have to select at least one of the three games: football, cricket, and tennis. The question is, how many play all the three games? So just take 30 seconds, not more than that, students, so that you can quickly give me the answer. How many play all the three games? Right. And it is 3 students. See the next question. How many play cricket and tennis, but not football? How many play cricket and tennis, but not football? You can take 30 seconds. Okay, so see the answer is 7. How many play cricket and football? So it is 4 plus 3, 7. Right, now see the next one. We have in a class, I think it's a continuation. How many play football and tennis? Yes, quickly give me, find out the answer, students. Okay, and here goes the answer. Football is 5 plus 3, 8. All right. Right. See the next question. How many play cricket and tennis? How many play cricket and tennis? Right. And it is 4 plus 3, 7. See the next question. How many do not play football? How many do not play football? The answer is we should not include football circle. That's all. So just omit the football circle. All right. Yes. So it is 8 plus 4 plus 10, which is 22. All right. Yes. Right. How many do not play tennis? So from this circle, you can infer how many do not play tennis. And it is 6 plus 4 plus 8. Okay, which is 18. How many do not play cricket? Six plus 3 plus 10. 6 plus 5 plus 10. Correct. 21. How many play both football and tennis? Football and tennis, but not cricket. So you have to just see it and quickly give me the answer. How many play football and tennis, but not cricket? It is 5. Right. Now let us answer another question with 4 sets. Right. So far you saw only 3. Now we have 4. Okay. So you can just take your 1 minute time to understand what this question is, especially what this diagram is. In a class of 80 students, students have to select at least one of the 4 games. Kho, kabaddi, volleyball, basketball, represented by a rectangle. So now this is a new addition. So it is represented by the rectangle. Okay, details given below are. So you can see the details for Kho, kabaddi, volleyball, and basketball. Okay. So how many selected all the 4 games? Actually, it's a simple question only. How many selected all the 4 games? Yeah. And it is 4 students. Okay. So how many selected? 4 students. Okay. Right. See the next question. Which is inside all the 4 figures? Which is inside all the 4 figures? Which is inside all the 4 figures? Okay. Next. So how many selected all the 4? We have understood how that 4 came. Which is inside all the 4 figures is also clear. That is same. The 4 students are the one which is inside all 4 figures. Okay, see the next question. How many selected only basketball? How many selected only basketball? It is 13 students. That is the one which is inside the rectangle, that is basketball rectangle, only that you should take. Okay, right. Next, how many selected Coco and Kabaddi? How many selected Coco and Kabaddi? It is one student, right? It's the one which is outside the rectangle, but inside Coco and Kabaddi. Right. Now see the next question. How many selected Coco, volleyball, and basketball? How many selected Coco, volleyball, and basketball? It is 5 plus 4 is equal to 9. Okay, so this is how you got, which is inside the Coco, basketball, and volleyball. Okay, so it is 5 plus 4, which is 9. Right. Now let's move on to mathematics, LCM and HCF. So you can quickly take down your notebook so that you can work it out and see. So LCM and HCF are very important as discussed earlier. Right. So now consider the multiples of 2 and 3. So multiples of 2 is what? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and so on it goes. So multiples of 3 is 3, 6, 9, 12. The 3 table you have to just write. Okay. Let us identify the common multiples of 2 and 3. So what are common among this 2 and 3? So you can see we have 6, we have 12, 18, 24, 30, 36, 42. So it goes like that. Okay. Now the common multiples of 2 and 3 are 6, 12, 18, 24, 30, 36, 42, and so on. Okay. Right. So the least common LCM is, it is 2 and 3, that is 6. Okay. So the least common is 6. All right. So consider multiples of 4 and 5. You have multiples of 4 and 5 means it is 4, 8, 12, 16, 20, 24, 28, 32, 34, 32, 36, 40, 44, and so on. Okay, so it's infinite numbers. Likewise, for 5 it is easy, isn't it? So you just have to write 5 table. 5 ones are, 5 twos are, and the very easiest table is 5 table and 10 table. Both are the easiest, isn't it? Okay. So 5 table you will have 5, 10, 15, 20, and so on. Okay. Now let us identify the common multiples of 4 and 5. So probably if anything ends in 0 and ends in 5, then it is divisible by 5, right? So what are the common numbers? So very simple actually, 20. Next I have 40. 60. 80. Right? Let us identify the common multiples of 4 and 5. The common multiples of 4 and 5 are 20, 40, 60, 80. So the least among that is 20. So that is called as least common multiple. Right? So that's called as least common multiple. So this least common multiple of 4 and 5 is 20. All right. Now see the next one. Consider the multiples of 4 and 6. So for 4, it is 4 ones are 8. 4 ones are 4, 4 twos are 8, 4 threes are 12. Likewise, 4 fours are 4 fives are. So it comes to 16, 20, 24, 28, and so on. Next, multiples of 6, it is 6, 12, 18, 24, 30, and so on. Right. Now let us identify the common multiples of 4 and 6, which is 12, 24, 36, 48, 60, 60, then next is 72, 84. Okay. All right. So these are the common multiples of 4 and 6. And the common multiples of 4 and 6 are 12, 24, 36, 48, 60, 72, and 84. Among that, the least one is 12. Among that, the least one is 12. Okay. Right. Now see the next question. Consider the multiples of 4 and 12. So quickly write down in your paper and see so that we can find out the least. So with this, we are getting the multiples of 4. Okay. Next to 20 as usual. So now let us identify the common, which is 20, 40, 60, 80. So the common multiples of 4 and 10 are this, and the least in that is 20. Right. Now like that, let us go to 6 and 8. So it is 6, 12, 18, and so on. For 8, it will be 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, and so on. Okay. So now let us identify the common multiples of 6 and 8, which is 24, 48, 72. In that, the least is 24. Okay. Right. Now see the next one. Let us see the common multiples of 6 and 10. So for 6, it is 6, 12, 18, 24, and so on. For 10, it is 10, 20, 30, till it goes. So now let us identify the common multiples of 4 and 6, which is 30, 60, 90. In that, the least one is 30. So that's the least common multiple, LCM. So the least common multiple of 6 and 10 is 30. Okay. Now let us find factors of numbers, right? So you see here, consider 2 into 3 is 6. Consider 2 into 3 is 6. So 6 is a multiple of 2 and 3. And 2 and 3 are factors of 6. Okay. So 6 is a multiple of 2 and 3. 2 and 3 are factors of 6. So consider number 4. Let us recollect 2 and 4 multiplication tables. So 1 into 4 is 4. 2 into 2 is 4. So 1, 2, and 4 are factors of 4. Now consider number 6. Let us recollect 2, 3, and 6 multiplication tables. So 1 into 6 is 6. 2 into 3 is 6. So 1, 2, 3, and 6 are factors of 6. Okay, so 1, 2, 3, and 6 are factors of 6. Okay, right. Now consider number 8. Now let us recollect 2, 4, and 8 multiplication tables. So we have 1 into 8 is 8. 2 into 4 is 8. Therefore, 1, 2, 4, and 8 are factors of 8. Now consider the number 10. Let us recollect 2, 5, and 10 multiplication tables. So it is 1 into 10 is 10, 2 into 5 is 10. So 1, 2, 5, and 10 are factors of 10. Now consider the number 12. Okay, let us recollect 2, 3, 4, 6, and 22. 2, 3, 4, 6, and 12 multiplication tables. So 1 into 12, 2 into 6, 3 into 4. Okay. Now 1, 2, 3, 4, 6, and 12 are factors of 12. Right. Now consider the number 12. Let us recollect 2, 3, 6, 9, and 18 multiplication tables. So 1 into 18, 2 into 9, 3 into 6. Right. So 1, 2, 3, 6, 9, and 18 are factors of 18. Right. Now consider the number 24. You have 2, 3, 4, 6, 8, 12 and 14. Okay. 8, 12 and 24 multiplication table. So we have 1 into 24 is 24. 2 into 12 is 24. 3 into 8 is 24. 4 into 6 is 24. So 1, 2, 3, 4, 6, 8, 12 and 24 are factors of 24. Now consider the number 30. You have 2, 3, 5, 6, 10, 15 and 30 multiplication tables. So 1 into 30 is 30. 2 into 15 is 30. 3 into 10 is 30. 5 into 10, 5 into 6 is 30. So 1, 2, 3, 5, 6, 10, 15 and 30 are factors of 30. Right, now 32. Let us recollect 2, 4, 8, 16 and 32 multiplication tables. We have 1 into 32 is 32. 2 into 16 is 32. 4 into 8 is 32. Therefore, 1, 2, 4, 8, 16 and 32. They are the factors of 32. Now let us consider the number 36. So 2, 4, 2, 3, 4, 6, 9, 12, 18 and 36 multiplication tables. Okay. Yes. So 1 into 36, 36. 2 into 18, 36. 3 into 12, 36. 4 into 9, 36. 6 into 6, 36. Right. So 1, 2, 3, 4, 6, 9, 12, 18 and 36 are the factors of 36. Right. Now what are the common factors? So consider 6 and 8. So let us write factors of 6 and 8. So the factors of 6 is 1, 2, 3, 6. Right. So how do you put this? We just have to take LCM of 6. So 2 3s are 6, 3 1s are 3, like that. So 1, 2, 3 and 6. Okay. So now factors of 8. So it is 1, 2, 4, 8. So in this, what all is common? 1, 2 is common, right? So we write common factors of 6 and 8 are 1, 2. Okay, common factors of 6, 8 are 1 and 2. Right. In this, highest common factor is 2. Okay, now next you are going to consider 8 and 12. So you can quickly do it by yourself and then try check the answers. I'm just giving you 1 full minute. Quickly do it by yourself and check the answer. So actually, it's very simple. You can take 1 full minute and get the answer. Yes. Here, let us write the factors of 8 and 12. So it is 1, 2, 4, 8, like that. The factors of 12 is 1, 2, 3, 4, 6, 12. In this, the common is 1, 2, 4, right? So therefore, common factors of 8 and 12 are 1, 2, 4. Okay, so 4 is the highest common factor. Right? So 4 is the highest common factor. Next, we are going to see 12 and 18. So let us write factors of 12 and 18. How do you write the factors of 12? 1, 2, 3, 4, 6 and 12. For 18, it is 1, 2, 3, 6, 9 and 18. So the common among them are 1, 2, 6. 1, 2, 3, 6. Okay. So common factors of 12 and 18 are 1, 2, 3 and 6. So 6 is the highest common factor, right? So the lowest is 1. Right. Now see the next one. Consider 12 and 16. Let us write factors of 12 and 16. So factors of 12 is 1, 2, 3, 4, 6 and 12. And factors of 16 is 1, 2, 4, 8, 16. Right. So the common is 1, 2, and 4. So common factors of 12 and 16 are 1, 2, and 4, and highest is 4. Okay. So this is how actually we check the right. See the next one. Consider 16 and 18. So in this, let us write factors of 16 and 18. So how do you write the factors of 16? It is 1, 2, 4, 8, and 3. Okay. How do you write the factors of 18? 1, 2, 3, 6, 9, and 18. Okay. So in this, you have to just circle the common one, which is 1, 2. Okay. So that's all. 1 and 2 are only common. Therefore, common factors of 16 and 18 are 1 and 1, 2. In this, the highest factor is 2. Okay. So the common is 1, 2. And in this, the highest is 2. Okay. Right. Next, 12 and 24. Right. So we have 12 and 24. Right. So yes. Just seeing the answer that is being given by what? Yeah. Okay. Right. So let us write factors of 12. That is 1, 2, 3, 4, 6, 12. Right? The factors of 12. Next for 24, it is 1, 2, 3, 4, 6, 8, 12, 24. The common among them is 1, 2, 3, 4, 6. Okay, 12. So common factors of 12 and 24 are 1, 2, 3, 4, 6, and 12. Okay, right. Next. So 12 is the highest common factor, HCF. Yes. So hope it's clear. Right. So second. There is an interesting relation between any two numbers, their LCM and HCF. Let me repeat. There is an interesting relation between any two numbers, their LCM and HCF. Okay. So all right. Now see here. Consider 6 and 8. So LCM of 6 and 8 is how much? 24. Right. So you all know 2, 6 will go on 2, 3. Then 3 and 1. Okay. And next you have 8. 8 is together you take 6, 8. So you get 24. So HCF of 6 and 8 is 2. So check the products of LCM and HCF. That is 48. Yes. So now check what is 6 into 8, 48. Okay. Yes. It's clear, no? You just have to multiply the numbers. And now you have to, that would be same as multiplication of your HCF and LCF. Now let us consider another example 12 and 10. So let us consider another example 12 and 10. LCM of 12 and 10 is equal to 60. So HCF of 12 and 10 is 2. Okay. So the LCM of 12 and 10 is 60. HCF of 12 and 10 is 2. Now check products of LCM and HCF. LCM into HCF is what? 60 into 2. That is 120. Okay. So what is the product of the LCM and HCF? Nothing but 60 into 2, which is 120. Right. So now check 10 into 12, which is 120. See, time and again, our answers are getting proved, isn't it? Yes. Yes. So you need to make any more things, you can do it actually. Anything that you need to write, you can quickly note down. So it is 12 and 10. All right, now let's move on to the next question. So we have two numbers, A comma B, that is A into B is equal to LCM into HCF. Okay, so what is that? We have two numbers, A comma B. A into B is equal to LCM into HCF. Now let us discuss even and odd numbers. Okay, so let us discuss even and odd numbers. Yeah. Right. Now see the next thing in this. Let us find the factors of 2. Now let us find the factors of 2. It is 1 into 2 is 2. Now 1 comma 2 are factors of 2. Right? Yes. So for 2 it is 1 comma 2 only. No, right? Next, so number 2 has only 2 factors. Numbers which have exactly 2 factors are called as prime numbers. Right? So what is the meaning of this? That number must be divisible by its own number or 1. So in that case, it is prime number. For example, we have the 13. Sorry, we have, let's take 7. Prime number, right? 7. So 13 is also a prime number only. Now for easy understanding, let's take 7. So if you multiply anything, you get 7? No. So for 7, the only 2 factors are 7 itself or 1. That's all. Okay. Right. So now let us have a look at other prime numbers. So we have 2, 3, 5, 7, 11, 13, 17, 19, 23. So total we have 9 prime numbers before 25. So total we have 9 prime numbers below 25. So 29, 31, 37, 41, 43, 47. That's the total of 15 prime numbers below 50. So you need to remember all this rules. Okay. So total 9 prime numbers below 25. Next you have total 15 prime numbers below 50. So there 9 and the balance is 29, 31, 37, 41, 43, 47. Next we have 53, 59, 61, 67, 71, 73, 79, 83, 97. So total of 25 prime numbers below 100. Right? So totally we have 25 prime numbers below 100. All right. Here 2 is the only even prime number. So prime numbers have exactly 2 factors, 1 and itself. Let us have a look at other prime numbers. Prime numbers that have exactly 2 factors, 1 and itself is 3. Factors of 3 are 1 and 3. Factors of 5 are 1 and 5. Factors of 13 are 1 and 13. Factors of 17 are 1 and 17. Okay. So numbers which have more than 2 factors are called as composite numbers. So numbers which have more than 2 factors. Okay. The numbers which has more than 2 factors are called as composite numbers. So we have 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, etc. So they are all called as composite numbers. So factors of 4 are 1, 2, and 4. That is 3 factors. Factors of 6 are 1, 2, 3, and 6, that is 4 factors. Factors of 20 are 1, 2, 4, 5, 10, 20. Other than these numbers, it is not visible. So we have 6 factors. Factors of 18 are 1, 2, 3, 6, 9, and 18, where you have 6 factors. Right? So number 1 is neither a prime nor a composite number. Right? But 2 is the even number, and it is a prime number. Here number 1 is neither a prime number nor a composite number. Okay, right. Now let us see prime factorization of numbers. Consider a number 6. So it is nothing but 2 into 6. Okay. So here both 2, 3 are prime numbers. So here both 2, 3 are prime numbers. So let us consider another example. Now prime factorization of numbers. Consider a number 8. So we can write 8 as 2 into 4. So here 2 is a prime number, but 4 is not a prime number. So we can write 4 as 2 into 2. So 8 can be written as 2 into 4, 2 into 2 into 2. Now let us consider another example. So prime factorization of numbers, we are considering a number 12. So 12 can be written as 2 into 6, which is, we can further write 12 as 2 into 2 into 3. So 2 2s are 4, 4 3s are 12. So writing a number in terms of factors is called as factorization. Alright, so I repeat, writing a number in terms of factors is called as factorization. So now let us consider another example, prime factorization of numbers. In that, writing a number in terms of its factors is called factorization. Writing a number in terms of prime numbers is called prime factorization. So writing a number in terms of prime numbers. So prime factorization of numbers means, let us consider another example. So here find the factorization of 24. So we have 24, you can write 2 into 12, 2 into 2 into 6. That is 2 2s are 4, 4 6 are 24. 2 into 2 into 2, 2 2s are 4, 4 2s are 8, 8 into 3, 24. Right? So by doing all these things, we are getting the prime factorization. Okay, right. See the next one. Prime factorization of numbers. Let's consider another example. Find the factorization of 18. 18 can be written as 2 into 9, 2 into 3 into 3. So prime factorization of numbers. Let us consider another example. Find the factorization of 28. 28, you can write it as 2 into 14 or 2 into 2 into 7. So next we have another example, prime factorization of numbers. So let's consider another example. Find the factorization of 10, which is 2 into 5. Now let us consider another example. Find the factorization of 16, which is 2 into 8. So 2 into 2 into 2 into 2. Next, let us consider another example. Find the factorization of 36. We have 6 into 6. So 6 you can write it as 2 into 3. Again 6 you can write it as 2 into 3. So putting it in ascending order, you get 2 into 2 into 3 into 3. Okay, right. Next, prime factorization of numbers. Let's consider another example. Let's consider the prime factorization. Right. So now find the factorization of 100. So 100 is equal to 10 into 10. So 2 into 5 into 2 into 5. Right. So 2 into 2 into 5 into 5. Right. Now let us consider another example. Find the factorization of 1000. Find the factorization of 1000. So you can take 1 minute to find out the answer for this, not more than that. 10 into 10. 10 into 10 is 100. 100 into 10. Okay. So 10 can be written as 2 into 5, 2 into 5, 2 into 5. Bring all 2 in one case where you get 2 into 2 into 2 into 5 into 5 into 5. Right? Now let us consider another example. Find the factorization of 2100. It can be 21 into 100 or 3 into 7 into 10 into 10 or 3 into 7 into 2 into 2 into 5 into 5, which is same as 2 into 2 into 3 into 5 into 5 into 7. Now another example, find the factorization of 2100. So, right, so 1616 into 100, 4 into 4 into 10 into 10. Likewise, 2 into 2 into 2 into 2 into 2 into 2 into 5 into 5. Right? Now another example, we have 2100. So 1616 into 100, right? Right. So now with this, we end up our Venn diagram, LCM, and our HCF. So hope you all would have noted down very important questions, what all we have discussed. So I'm sure you would have got benefited by this. Okay, all right. So any doubts, you can always write to us and explain about our classes and discuss about our classes to your friends, your teachers, your neighbors, so that they can also join and get benefited by this classes. Right? So all the very best for your forthcoming classes. And please do take up the test that is being conducted by our group. Okay? And happy Children's Day once again. Thank you, children.